So this is a paper that is a little bit technical, but I'll try to keep the technical details as minimal and as clear as possible. It's a paper that I've penned with James Harrigan and Farid Tubal. So, so what is this paper about? So it's it really dovetails quite nicely with two of the presentations that we saw yesterday by Professor Morin and Professor Breda, and it's really about technological change and can we identify the micromechanisms that really drive technological change at the firm level. So the broad question really is, what are the drivers of productivity growth? This is something that we would like to know in general, and when you start thinking about this more in detail, when you think about innovation, when you think about technological change, there are technologies that are in some sense ephemeral, they exist, and then the question is, how does this diffuse into the economy? How do these new ideas get implemented in productive activities? And then the immediate question is, what does this imply for labor? And so what we're going to do in this paper is actually look at firm level data for the entire French private sector, and use an indicator for firm level investment in new technologies. And this is what we call the techies. Okay, what are these techies? I will show you in a slide or two exactly. But think about these as engineers. Okay, engineers and technicians that are, as the slide indicates, these are creators or mediators of technological change. So creators, these can be people that are actually cranking out new molecules in pharmaceutical firms, or these can be chemical engineers that actually adopt existing knowledge into the firm. And while we cannot actually separate the role of the two, what we can do is, well, we can to some extent, because what we can do is to see of these engineers which ones are actually working on R&D projects, okay, and which ones are involved in ICT. So we're going to focus on those types of engineers, although there's a plethora of types of engineers in the data. Okay, and we think that this is an interesting idea because other works that have been done have relied on R&D data, so R&D expenditures or patents. Okay, and there are a lot of problems with these types of data. In particular, patents are not a particularly good indicator of the output of innovation. On top of that, R&D, the way it's recorded in the data, is also not a very precise indicator of the input into innovation because of all kinds of accounting rules and so on and so forth. And so what we're going to do is to study, using this approach, to study how R&D efforts and efforts in what we think is more likely the adaptation to new technology, to ICT technologies at the firm level, how does this affect productivity growth, and how does it affect demand for labor? And so in this whole process, I'm not going to highlight this too much today, but we're also really interested in the roles of globalization, so exporting and importing activities. So who are these techies? So broadly speaking, there are two classes, or maybe four classes, for groups of techies. So first of all, you have engineers and technicians, okay? And these are the classifications of the PCS. These classifications were mentioned yesterday as well. And within each group, within each class, the data actually allows you to see, starting from 2009 in these data, it allows you to see what are these people doing in the firm, okay? What is their role in the firm? And this is not a survey, so this is what the firms report that these people do. So we think that this is not a bad indicator of what their actual tasks in the firm. Okay, so the sketch of the methodology, what we're going to do with this is is to estimate something that's called a Hicks neutral and also skill bias productivity growth. So the Hicks neutral is for those that are not used to this terminology, it's a type of productivity growth that increases the productivity of all factors of production exactly proportionally in the same way. Whereas biased the productivity growth is a type of productivity growth that actually augments the productivity of one factor or another more than the others, okay? And clearly, maybe not so clearly, if one factor becomes more productive than the other, then the relative demand for that factor can be altered, okay? And it can actually go up or down, okay? It's actually not obvious whether if I become suddenly more productive in whatever I do, is demand for my labor service going to increase or decrease, okay? And that depends intimately on the structure of production. For example, if we need, in order to produce this lecture, we need only one Ariell and one Clement, and Ariell becomes more productive, twice more productive. In fact, the demand for my labor services goes down by half, okay? Whereas if it is easy to substitute between us, okay, then if I become suddenly more productive, demand for me will increase, okay? So I'm not going to dwell, I'm actually going to talk about that in a little bit more detail when I get through a little bit more technique, okay? So the idea is to estimate these productivity shifters. We're going to do this for all French firms in the private sector, excluding agricultural primary sectors and finance, okay? And then we're going to associate these things to, as I indicated, the firm level efforts in doing R&D, firm level efforts in developing or adopting ICT, importing and exporting activities, okay? And then we're going to evaluate the quantitative importance of these efforts for demand for labor, both at the firm level, and then we're going to do an aggregation exercise, okay? And what we're going to find is that firms that actually are doing these types of activities see greater productivity growth, okay? In particular, the techies are indicative of faster productivity growth. So comparing two firms, one that has more techies versus the other, the one that has more will, in fact, grow more. It is going to happen through a biased process, okay? This is perhaps not terribly surprising because a neutral process is a knife edge situation, okay? To have everything completely balanced is the unlikely event, but the bias is actually large, okay? And this is what we want to quantify. When we aggregate the overall firm, and also importing. So exporting does not entail productivity growth at the firm level, okay? But importing does, okay? And so this is an indication perhaps for all the people that are engaged in trade wars, okay? And then we're going to aggregate, and we're going to actually find very sizable effects on aggregate relative demand for skilled labor, okay? On the order of magnitude of what we actually see in the data. So, and this is very important and reassuring because this paper goes through several loops, several hoops. It jumps through several steps, and in the end, when you take all of this stuff together, it actually adds up to something reasonable. And for us, this is actually kind of important. And one of the takeaway messages that we're trying to push with this paper is that these techies, these engineers, actually most of them are not involved in R&D per se. They're not inventing new things. They're bringing technologies that exist into the firm. And if this is true, then it has actually some interesting implications for education policy, okay? So a little bit about the intellectual underpinnings. So we're economists, so we don't cite too much literature from business schools, but the first bullet point is actually citing some interesting papers of people that actually do work in business schools, in particular at MIT, at Wharton, where these papers also highlight the importance of IT and IT workers in not only in output growth, not productivity, importantly, but also in the diffusion of technology. So in the sense that when an engineer, one of these, the last paper, the Tam Ben Hit paper, is a fantastic paper which relies on a fantastic data set that actually shows that there are technological spillovers, from people that, that move from firms. So IT people that gain experience in a firm, this firm grows, and if these people actually move to other firms, they take with them some of this productivity to the next firm. And it does it in a relatively convincing way. We have a previous paper, and actually also a little book about polarization in France, where we talk about this idea of techies, where we illustrate that the employment share of these techies is actually increasing quite nicely in France, from about 8% in '94 to 14% in 2013, and most of this growth is actually engineers, not technicians. Okay. Then there's this other paper by Richard Freeman and co-authors, where they go into similar data with some other features, similar data to what we have for France, for the US, and they actually illustrate that most of the engineers that you see in the data are not involved in R&D, and yet they are associated with greater output and greater output growth. Okay, and this is also the case in the French data. The minority of engineers are actually involved in R&D activities, and we can actually show that much more clearly than what they can. And so now there's these really fascinating and by no means not uncontroversial papers by economic historians, but I think that the ideas are actually kind of interesting. So the common denominator of these papers is Yoel Mokir, who I quote from one of these papers. I think it's actually the 2012 paper. That the British advantage, so it's a paper about the Industrial Revolution. So the question was really, why did the Industrial Revolution happen in England and not in France, where a lot of indicators of knowledge and progress were actually quite similar on both sides of La Manche. And so what they argue, and once again, this is by no means not incontroversial, that the advantage of the British, of the English, was this system of apprenticeships, where you had a much broader supply of people that could actually implement technologies, people that had basic technical needs. They were not the inventors, okay? They were not highly skilled engineers, but these were technicians that you could actually hire at relatively cheaper prices. So part of what they discuss in these papers is, in fact, the relative wage in real terms of this class of people in England versus France. And the data are very clear on that. These people were very cheap in England, much more much cheaper in England relative to France. And then there's this other paper by Moloni and Valencia Caicedo that this is also a thought-provoking paper, but they actually correlate income levels across Latin American countries or across U.S. counties with the engineer intensity of these counties or these countries, regions actually. This is not cross-country. This is regional data in 1880. Basically saying that the foundation of productivity growth, all this good stuff that has happened from the end of the 19th century till today, is really associated with standing on the shoulders of giants. But these giants, we can actually count them in 1880, and this predicts, it's an incredibly strong predictor of productivity, of output today, of welfare in some sense. And just very briefly, I don't want you to look at all these references, but what we're doing is related, it's very intimately related to the presentations that we saw yesterday. We are going to touch upon these ideas of skill-based technological change, directed technological change, these ideas about routinization. What is the nature of technological change currently today? These computers are replacing tasks that are codifiable, that are repetitive, and this relatively more recent literature about the race against or with the machine. So is artificial intelligence really going to replace all the labor? We're all going to be unemployed, okay? So we'll have something to say about these things. We're also going to touch on these ideas relating importing and offshoring to productivity growth. So the firms that are doing offshoring, maybe they're hurting demand for local labor, but they're not doing it because they hate or like one type of labor or the other. They're doing it in order to increase their profitability and increase their productivity. Okay? And then there's this other literature that highlights the complementarity between exporting and investments in technology, and how this can actually be biased towards skilled labor rather than unskilled labor. And the idea here is very simple. You know, investment in general it can always be seen as a fixed cost, and you need to spread this fixed cost over many units of selling, right, of sales. And so having greater access to export markets means that you can, in principle, sell more units. And so it makes investment more profitable. So this is the market size investment complementarity. And Philippe Aguillon has a recent paper that shows this very convincingly for French firms. Okay, so I don't want to talk too much about technique, but a little bit fixing ideas of what we have in mind is probably useful. So one simple equation can maybe highlight a few things. So suppose that you are a firm and you start your life with some level of productivity, omega, okay? And then you have a choice. Do you hire techies or not? Do you invest in better technology or not? Well, you're going to do that only if it's profitable. So this function here is illustrating the fact that you can choose how many techies to hire, and this can be true for any type of investment in technology. But you know, if the gain is too low, okay, then you will not do it, okay? So you make an optimal choice about these things. And in order to hire these techies cost something, so there's a price. Here's their little price. This is the R. And there may also be a fixed cost of doing that. So actually, bringing in techies, if you didn't have any, may entail a fixed cost, okay, an organizational change cost, okay? And so this framework actually gives some very reasonable and simple predictions, which is that you're going to be less likely to employ techies when their profitability for your firm is low, when fixed costs are high, when you cannot spread the investment over many units, if your market size is small. Okay. If you are to hire techies, you're more likely to hire more of them when the opposite is true, when they are more productive and when the market size is large. And so, without going into too much detail, this is actually what we find in the data. So, broadly speaking, you want to know where are these techies in the French economy, which type of firms hire them. Well, these are firms that are bigger. They have a higher sales. They are exporters. They are importers, and firms that are more skill intensive. Okay. And then if you just look at those that have techies and compare which ones have more, then you see indeed these are, once again, firms that are bigger, firms that are exporters. There's actually some consistent with theory. It's actually, you would not find more techies conditional on having them if you are an importer. And because it's actually importing per se is not an indication of market size. And then also in firms that are more skill intensive. Okay? So, so in order to get at all these questions of productivity and all that, we need to go through some hoops. Okay, I'm just going to check how bad am I doing on time. Okay, not so bad. So the classical approach to estimating productivity is taking a stand on the production function. Okay, how do firms produce? We're going to postulate a very simple production function that looks like that. So this is a production function that combines 4 factors. Low skill labor, high skill labor, capital, and materials. Okay? And there's something that's called the impossibility theorem that says basically that actually estimating what you care about, this omega and this omega jointly is impossible unless you make really strong assumptions on the evolution of these objects over time. Okay? But in fact, science progresses, and some people have found a solution to this issue. And this is a paper that is published in the American Economic Review that illustrates that, in fact, if you are willing to assume this structure of production, and if you estimate it by normalizing all inputs, you can actually do quite a lot. okay? And I will show you how that works. So the over bars here are just the same variables. This is the average, the geometric mean in the data of low-skilled labor employment, and so on for all these other factors. Okay? And so in order to estimate these objects and also to relate them to these techies, we need to make a few additional technical assumptions. First of all, we're going to think about techies as investment. Okay? They affect productivity. If you hire techies today, they will affect productivity only tomorrow. Okay? And the second assumption is that when you count output, you can think about this as the output of the firm is influenced by techies only through their effect on productivity. Because you can contemplate a world where techies are producing widgets, but they also contribute to the productivity of producing widgets tomorrow. And so we have some econometric tests that indicate that this is not, the way we look at this model is not unreasonable. Okay, I don't go into the details of that. Another important assumption is that firms are not stupid. They know their productivity. There's going to be a component that they don't know, but their actual productivity, their technical capability is known to the managers of the firm. Okay? I'll do this very quickly. There's going to be a demand curve that firms take into account, and this gives rise to a revenue function. Okay? And in the revenue function, this is the uncertainty. Firms can plan at the beginning of the year what they want to do, their hiring inputs, their marketing plans, and so on. But at the end of the day, they are hit with all kinds of demand shocks or revenue shocks, things that they cannot anticipate. And so the magic of this methodology gives rise to the fact that things that are unknown to the firm are actually substitutable. Okay? So forget about this part. This is a really technical point. But we use this technical point for productivity, for the biased productivity part. So the key message of this slide is that if firms are cost minimizers, firms are behaving in an optimal way, they take into account the productivity shifters of the firm. Okay? If this is true, then, for example, if skilled workers are more productive, the firm takes that into account in its optimal behavior. And by manipulating the optimality conditions, we can have a relationship between the employment of skilled workers times the unobserved productivity related to things that we do observe. So, for example, employment of low-skilled labor and the relative expenditure shares of skilled versus unskilled labor. Okay? And the other message and this is where this normalization magic comes in, if you take geometric means of these two expressions, you actually get relationships between these alpha parameters that are completely driven by data. Okay? So what is this? This is the average expenditure on materials in the data. This is the average expenditure on low-skilled labor in the data. And this, so normalization plus optimal behavior gives rise to these relationships between deep structural parameters that helps us estimate the entire production function. And so at the end of the day, after doing a little bit of algebra, and really not that much, you can have a really simple estimating equation from which you can estimate all the parameters of production function. Okay? This is an equation that allows us to estimate, the curvature of the production function, this ratio of the two distribution parameters alpha k, alpha l, so only the ratio, and the demand curve. Okay, the effect of demand. This is in fact the average markup. Okay, and it's relatively simple to do this. After you've done that, you can back out all of the other parameters of the production function using the conditions that we derived before and an assumption on the returns to scale of the firm. Okay, we can relax this assumption relatively easily. This is not key. And so after you've done this, okay, you can actually back out for every firm once you have all the parameters. All of these parameters, the alphas, the curvature, okay, you can back out exactly what omega H and omega S are. Okay, and importantly, we do take into account some degree of elasticity of demand, which does not vary by firm, but does vary by industry. Now, a little bit more in theory before I actually go into the results. It's important. So, I mean, it's important to understand how productivity affects demand for labor. Okay, this is the main motivation here, and so you can write the elasticity of different types of labor with respect to productivity shifters like this. Okay, and so if you increase your neutral productivity, okay, demand for skilled labor and unskilled labor increases equally. Okay, and if and so there's a reason why this is the demand elasticity -1. -1 because you just become technically more efficient. So holding constant sales, you don't need as many people. But on top of that, if the demand curve is elastic, then you actually want to move down your demand curve in order to increase profits. Okay. What more interestingly is the implications of bias technological change for demand for labor. So in the case of if demand for labor, if productivity is increasing more for the skilled workers, it's perhaps not very surprising that under really mild conditions, demand for skilled labor increases. Okay, so very, very mild conditions will imply that this square bracket is actually a positive number. Okay, but more interestingly, even if productivity is biased towards unskilled labor, towards skilled labor, the overall demand for unskilled labor can increase. And why is that? Within the firm, it wants proportionately less of the unskilled labor. But the gain in profitability, or the reduction in costs, is so big. It lowers the cost so much that the firm goes down the demand curve so much that the absolute level is increasing. Okay. And so, and our estimates will allow us to make statements about whether eta, this parameter, is greater than sigma. Okay? So the main effect, the obvious effect, is that if skilled labor becomes more productive compared to unskilled labor, in relative terms, you will want to hire more skilled labor. This is not the issue. The issue is whether that relative is greater than the absolute increase in scale of the firm. And that is governed by whether your demand elasticity is more elastic than your substitution elasticity. And so then after cranking out all of these, so that was enough on theory. After we crank out all of these productivity shifters, we can regress them on techie employment, indicators for exporting and importing. Okay? There's some technique that goes into the estimation that I'm not going to discuss right now. Okay? What is important actually is that when you regress, for example, the neutral part of productivity, you're also controlling for the lagged level. And so that when people worry about endogeneity of these types of relationships, the most important concern is selection. Okay? And this thing controls for selection. So while not being, estimating these equations does not give you what we call in econometrics the average treatment effect, it does give you the local average treatment effect, in the sense that it gives you what was the effect on productivity of hiring techies, for example, for the firms that decided to do so, not for what would happen if I gave the average firm more techies. Okay? So that's what those are the statements that we actually can make. And so we're going to use data. What is the time? Do I have 5? 10 minutes. Okay. So we're good. So then, so we'll even have time for questions. So we're going to use data from the administrative data sets of France. We're going to call our skilled workers. These are basically managers and non-R&D and non-ICT engineers. Okay. The L workers are going to be, the low-skilled workers are going to be virtually everybody else. And we have these techies. We're going to be able to separate them between ICT, R&D technicians, and engineers. Okay? We're going to use balance sheet data for the firm in order to compute capital stocks. There's actually some technique going into that. We're going to use data from the French customs to tell us which firms are exporting and importing, and in the paper we also study at some point, you know, the intensity of these activities. And what's nice about the French data is you can merge everything, because the French identifiers are common to all the administrative data sets. And we're going to look at this relatively short sample because we can't do what we are doing before 2009, okay? In particular, this is something we cannot do before 2009. So when you estimate these production functions, you get parameters. So I don't expect you to read this entire table. But what I want to say using this table is that the estimates are actually quite reasonable. What do I mean reasonable? What is that? What is the benchmark for that? So first of all, they lie in a range of parameters that is not totally crazy, that is not outside of the range of things that have been estimated in the literature before. On top of that, if you look at variation, for example, in elasticities of demand, they actually line up in a reasonable way with what you would have expected. For example, this very, very high elasticity of demand, almost 12, in retail, well, what does that imply? It implies that margins in retail are very small, and that's exactly what happens. Similarly, in wholesale, an elasticity of 8 implies very, very thin margins. This is exactly how these industries operate, compared to a relatively low elasticity of, let me choose one, you know, for example, in computer and electronic products, where there's more product differentiation, the elasticities are lower. Okay, so all these numbers actually kind of make sense. For example, another obvious example from wholesale and retail is that the share of materials is high. This is exactly what these industries do. They bring in a lot of things to their store and they ship them out. So the importance of materials in their production process is important. Okay, capital intensity is higher in, for example, transportation and storage, in machinery and equipment, and so on and so forth. Okay, so the numbers actually make sense. On top of that, the elasticities of substitution across factors are also very, very reasonable. And there's nothing, I have to say that nothing in the estimation forces these numbers to sit in that way. Okay, so it's kind of a pleasant surprise for us that things actually lined up nicely. Another implication of these estimates is that indeed the elasticity of demand, broadly speaking, is much greater than the elasticity of substitution, which gives rise to these mechanics that I talked about just before, that even if firms are increasing productivity in a biased way, by hiring more skilled workers, in relative terms, the firms that do that gain so much in average productivity that they are able to move down their demand curves a lot and increase their scale so that the relative of low skill is decreasing, but the absolute level is increasing so much so that it outstrips the relative decline. Okay. And this gives rise to the possibility, not a proof, but the possibility that the changes that we are seeing, so these, you were saying yesterday, the big firms became big precisely because they did something technologically. Okay? If that is substituting, for example, the internal promotion, well, it's not clear that the aggregate internal promotion is decreasing, right? To the extent that it is because other firms are doing, not participating in this game, and so on and so forth. And so, okay, so here are tables that show you what we actually estimate in the end, okay? So the baseline specification implies that techies, these techies have a big effect. So I'm going to interpret these numbers in a bit, okay? Techies have a big effect on the skill augmentation, so on productivity growth through skill augmentation, not on neutral productivity growth. Whereas importing has an effect both in a biased way and in a neutral way. Okay. So what this means is that when a firm that imports, the importing has these both effects. Even if you shut down this channel, the other channel is still operative. That's, I guess, the right interpretation of these findings. So what do you do with this? So using these equations that I showed you before about demand for labor, demand for skilled and unskilled labor, we can interpret these coefficients using all of the results. Doing that implies, using the results of these regressions and the parameter estimates that we have estimated in the first part, in the first stage, and you can make statements like this. So comparing a firm at the 75th percentile of Techies, so a firm that has a lot but not ridiculously a lot, to a firm that doesn't have, so this firm is going to have 60% higher employment of skilled labor, is going to have 15% higher employment of unskilled labor. Okay? So and remember that the Techies are only operating on the bias part. So this implies that this is exactly a manifestation of my statement about elasticities of demand. Even though you want to substitute unskilled and hire more skilled, by doing that, you increase your productivity, you decrease your cost structure in some sense so much that you actually outgrow that relative decline. And so the relative increases. It's almost this minus this. If you look at importing, you have a similar effect, only the effects are at the firm level are bigger. Okay? And the key message is that demand for both skilled and unskilled workers is increasing for firms that import and for firms that hire Techies compared to other firms. And then what you can do with these, you can try to aggregate these numbers. Okay? And doing that is a slightly complicated process, but it's doable. And so if you look in the data, the relative demand for skill increases by 1.8 percent points between 2009 2013. This is the boundaries of our data. Not a very long time, but that's what we have. So you combine the estimates and all these parameters and plug in what firms actually did. Okay? So filter the choices of firms through the parameters that we have estimated and see what does this imply for aggregate demand. And what it implies that Techies, the choices of employment of Techies have increased the relative demand for skilled labor by 1.12% and importing even more. Okay, we saw that the importing on the margin it has a bigger effect. Okay, so the effects here are large. Okay, you need to take them with a grain of salt, and maybe this is a big grain of salt. These calculations completely ignore equilibrium conditions. Okay, it's basically a quantification of a demand shift, not of what would actually have happened if, for example, if you want to hire more Techies, well, that's going to increase demand for Techies, and the price of Techies will go up, and maybe that will counterbalance these things, and so on and so forth, industry equilibrium conditions, and so on. But like I said in the beginning, it's reassuring that after going through all those technical hoops, you get, in the end, a quantification that is not completely berserk. Okay? Then we start talking about, is it the R&D or the ICT? Okay? Then things get a little bit more tricky. Okay? So we see that on the margin, in fact, ICT has a twice as large an effect as the R&D effort. So so that's on the margin. So this is the question of what would happen if a firm increased R&D expenditure a little bit, in a similar way, ICT expenditure a little bit. But however, if you try to quantify this in what do firms actually do, the differences are smaller. Okay, but still, it's telling you that the ICT efforts and the R&D efforts are comparable. And if you think that these ICT engineers are actually not inventing anything particularly new, they're just implementing existing technologies, this is a statement that says technology diffusion is not less important for productivity growth than actual, pushing the boundaries of what is possible. We also, perhaps not surprisingly, we find that all of the effects are coming from engineers, not from technicians. Okay, and then we also go into comparing what types of importing is important. So it turns out that the importing effect on, even though some statistical power decreases, the importing effect on the biased part of productivity growth is actually happening through intermediates. So this lines up with stories about offshoring, where you substitute low skill labor with imported inputs. But interestingly, the effect on the neutral part is actually more coming from high-income countries compared to low-income countries. So there's a trade-off there. If you're importing intermediate inputs from low-income countries, you may be sacrificing neutral gains in favor of bias gains, okay? And so I guess I'm out of time, so I'll just conclude. So what did we learn? So, you know, this is a little bit self-promotion, but this is really the first paper in this type of literature that tries to evaluate all these different channels at the same time. And we think that this is important because they seem to be correlated. Firms that export also import, also invest in technology, and so on. And then what do we find? We find that these techies are important for productivity growth through a biased productivity process. Importing is also important through both channels. It has large effects on relative demand for labor, but also not necessarily absolute. It's not clear that low-skilled labor needs to lose in absolute terms. And so, you know, the broad message is really that these techies seem to be important for productivity growth. And then, you know, if this is true, and if it's really more about technology diffusion, then maybe we want to have more of these people. You know, it's a big question. You know, I think that economists should be very careful when they give policy advice. But in particular in this case, because it also depends on what skills you give these engineers. Okay. But it does open the door to making statements about that these engineers they don't actually need to be, you know, sorry if I'm offending anyone, they don't need to be the polytechnicians of the world, okay? They can also be the people that go to the engineering schools in Lyon and so on, and in Marseille, that are actually contributing to productivity growth at the aggregate level, perhaps not less. Clearly, the envelope of science is driven by the best and the brightest. This is not, I don't think that that's controversial. But even if you're not pushing the envelope, you have a role, and an important role at that, in bringing these great ideas, in bringing these technologies into the firms where you are employed. And I'll stop there. I'm happy to answer questions if there is time. Yes?
Why is it that it's not export that's driving the show?
Yes.
The question is, why is it that it is imports that's driving the point as opposed to export? My intuition would be that take two companies, everything equals. The one that export will be facing competition in all areas, and because of that, will be tended to have the best techie people. So
This is an excellent point.
But
so I can explain this. The firm that is an exporter, that is bigger and more productive than all the other firms, started with a very high productivity level. Okay, so and there's a large literature about that in international trade using firm-level data, and I think that the broad consensus about that is that the decision to export is based on selection and not on productivity growth. In other words, in developed countries like France, you don't see this phenomenon that we call learning by exporting. So there's no, and this is what we're actually estimating, productivity growth, not levels of productivity. The levels are absorbed in the lagged, that's why it's so important to control for lags, okay? Learning by exporting is something that you can see during the period that Slovenia integrated with the European Union, okay? In a famous study. You don't find across the board learning by exporting, and if you do, these effects are really small for exporters. Okay? What you do find is that in periods of massive trade liberalization, there is some evidence that firms actually take actions to reap the benefits of market access. But in the context of France, which already has very, very high market access to all the important markets in the world, there's no reason to do investment in productivity growth due to export opportunities per se. So the firms that are exporters are the biggest, the best, the fastest, and so on. But they've already done those investments in the past. They've accumulated these things. So yes, that's the reason. Yeah.
So super quick. My main non-technical question regards your interpretation. Because you talk about ICT and R&D, the effects of ICT and R&D, but of course you do not observe ICT and R&D. You observe just people who work in ICT. But that immediately makes me spin my head about when should I hire an engineer? How many engineers should I hire, depending on the type of ICT I use? Like maybe 10 years ago, I had to hire 10 engineers for one single ICT tool. Nowadays, maybe things are much more easy to use, there's learning, and now I use less and less. So there are these kinds of questions which regard the way in which you frame the thing, because it could be just a paper on using techies per se, and that would be.
So the answer to that is twofold. First, from in alternative data sets, we actually know that the bulk of R&D expenditures is in fact on R&D engineers, except in particular industries. For example, in pharmaceuticals, you need to build a lab. Okay? And then, but even engineers and technicians that operate these labs are expensive, and so the lab is something you build once, and then the continual effort is better indicated over time by the expenditures on workers. So this is a separate thing. Then ICT, it's true, we're looking at the labor employed in ICT, not on the capital employed in ICT. So it is a drawback of the study. The ICT capital is counted in our capital stocks, but that may be misspecified to some sense, right? The issue, we can go into the technicalities of why it is incredibly difficult to actually control both for capital stocks and ICT capital, but yes, the interpretation would be, what we're picking up as ICT employment is also capturing the effect of investment in hardware, not only in people that install the software, develop the software, and so on. Yes, so this is admitted fully. And the last point is that yes, in the past it may have been different, but
these things may change over time depending on.
Clearly.
But today, when you basically spend services in terms of ICT, you go to Amazon Web Service and you.
So in this other paper that I mentioned, we actually document that is, while that seems to be very visible and sexy and so on, that's actually not the main game. So it may be important in the more important in the future, but today most of the IT activity is within the boundaries of the firms that employ them. These little shops, the tabak that need someone to come to fix the desktop, to do the accounting and so on. Yeah, there are many tabak stores, but they don't count for a lot of employment and productivity growth. Okay.